Good morning, everyone. Today we are going to study another important phenomenon of light, that is refraction. So in the previous class we have studied that what happens when light strike on an opaque surface. And even if that opaque surface is smooth and highly polished surface, very smooth surface, the maximum light falls on that surface reflects. Now if light enters into a transparent medium, what happens? Definitely it passes through it. Now when it passes through that medium, the light can pass through so many transparent medium. Air is a medium through which light can travel forward. Water and the transparent liquids are there through which light can pass through. And also the transparent solids light can pass through. Now the next question is that when light travels through these different transparent media, anything else happens. That's what we are going to study now. When light enters from one transparent medium to another transparent medium, what changes are taking place? You might have observed many times that if in a glass tumbler, if a spoon or a pencil is partly immersed, we can see that at the surface contact point between that air and water, from there onwards, that spoon or that pencil appear to bend. And at the same time, the lower surface of a swimming pool appears to be raised. And if we keep a glass slab on the printed letters, very small printed letters, these letters appears to be raised. All these are based on the phenomenon that is refraction of light. Here what happens, the light travels through more than one medium and there appears some bending. So that's what called as the refraction. Means refraction means when light travel from one transparent medium to another transparent medium, when it strike obliquely to another transparent medium. In the second medium, it appears to, the direction of propagation of light appears to change. When light enter from one transparent medium to another transparent medium, in the second medium, the direction of propagation of light appears to change. This phenomenon is known as refraction. Now, why this refraction takes place? It is because of the reason that light do not travel with the same speed in all the medias, all the transparent medias. Light travels with maximum speed in vacuum, and from that is about 3 into the in vacuum, the speed of light in vacuum, that is about 3 into 10 to power 8 meter per second. As it enters from the vacuum to air, a slight variation take place, very less variation take place. So here also we consider the speed of light in air also as near about 3 into 10 to the power 8 meter per second. But this is not same when it enters into the various liquids, various transparent liquids like water, the different types of oils, etc. Due to the arrangement of particles and the nature of particles, the speed of light in these medium get reduced. The same thing happens when it enters into the solid, the transparent solids also. The speed of light get reduced. So, and it is observed that the hardest substance diamond, the hardest substance, the light travels the slowest. So in this way, due to the variation of the speed of light in different transparent media, it undergoes the phenomenon that is called refraction. It appears to bend or it appears to deviate its path when it travels from one medium to another medium. That's what we call as the refraction. Now, the refraction of light we can study by considering the refraction of light through a glass slab. here, this is a rectangular piece of glass slab, and if we consider a light ray that is striking obliquely to this glass surface, we can see here this is a glass slab who is having two refracting surface. The first refracting surface is AB and then CD. Two refracting surfaces are there. And when a light ray obliquely strike on the first surface, AB surface, here we can see a normal is drawn. This is a normal to the refracting surface. This is normal N. This ray is known as the incident ray, and it makes an angle here, the angle of incidence. Now, the medium here, that is air, and this is the first medium, and here the second medium, that is glass. In such cases, when the light enters from air to glass, light has maximum speed in air. So here the air is considered to be a rarer medium. It is considered to be a rarer medium. So in a rarer medium, light travels with great speed. Since the light speed is less in glass, when we compare glass with air, here the glass is a denser medium. So glass is a denser medium here and air is a rarer medium. This is because in air speed of light is more, whereas in glass the speed of light is less. This is nothing related to, this is optical density. This is related to, here we are using the word denser, that is related to optical density. That means this is just only depends on the speed of light. It is nothing related to the mass density as we studied earlier. So here, and it is studied that when light enters from obliquely from rarer medium to denser medium, it usually bends towards the normal. So here angle of I and angle of R, angle of incidence and angle of R, this is the angle of refraction here, refracted ray. This is the refracted ray, and the angle formed here is the angle R. This is angle R, angle of refraction. In this case, angle I and angle R are not equal, because when light enters from rarer to denser, a bending of ray take place. Since the speed of light in the second medium glass, that is very slow, very less, the light ray, it bends towards the, since the speed becomes very less, and as a result it bends towards the normal. Here angle I and angle R are not equal, angle R is lesser than angle of incidence. That happens when light ray enters from a rarer medium to denser medium. So this is the refracted ray. Now we can see what happens to this ray when it comes out of this glass slab. So here again this normal, this is the normal to the next surface, refracting surface CD, and here the ray that is coming from denser to rarer, outside it is again air. So when it comes from glass to air, again it travels from denser medium to rarer medium. And when light strike obliquely from denser to rarer, its speed increases here again. Since its speed increases, it bends away from the normal. So here we can see the ray that is bent, that bends away from the normal and travels like this. This is the emergent ray. So incident ray, refracted ray, and the ray comes out, that is the emergent ray. Here one thing we can see, this incident ray, if we extend forward this incident ray, it's supposed to travel like this. This is the path, the extended pathway of this incident ray, and this is the pathway we get for the emergent ray. This is the emergent ray. Emergent ray, refracted ray and incident ray. Here what we see is this incident ray and the emergent ray becomes parallel to each other. This is because here the refracting surface AB and CD are parallel to each other, and since the difference in this speed of light in this different medium, how much is the extent of bending take place in the first refracting surface, that will be equal and opposite to the extent of bending taken place in the next refracting surface. So the extent of change of the path is equal and opposite. How much angle it bent towards, that much angle it bent away when it comes in the next refracting surface. So the incident ray and the emergent ray becomes parallel to each other. But one difference is that this emergent ray is shifted little to the side. This much is the distance that it is shifted from its original pathway to the emergent, the appeared path. And this is known as the lateral displacement here. So the ray is laterally displaced, but it appears to be parallel to the incident ray. So why it changed the path 2 times here? That is because the light travels from a rarer medium to denser medium, and from a denser medium to rarer medium. At these cases, in these mediums, the speed of light is not same, it is different. So in this way, refraction takes place. Now, the next topic we are going to see is refraction. This refraction of light, it always obeys certain laws. At any case, at any situation when refraction takes place, the refraction obeys certain laws known as the laws of refraction. The next topic is laws of refraction. The refraction obeys certain laws known as laws of refraction. The first law of refraction is same as we have studied in the reflection topic. The second point we studied that the incident ray, the refracted ray and the normal. Incident ray, refracted ray and the normal to the refracting surface. The normal lie in the same plane. This is because light cannot bend and travel to another plane, so these all lie in the same plane. And the next law says that for a given pair of media and given pair of particular color, the ratio of the sine of angle of incidence to the sine of angle of refraction, that is sine angle I to sine angle R. This is for a given particular color. Sine of angle I, the ratio of sine angle I and sine angle R, angle of incidence and angle of refraction, is a constant. It will be a constant, and that constant is known as refractive. It is known as refractive index. So for a particular color, the sine of angle I and sine of angle R's ratio will be a constant. This law is known as Snell's law of refraction. Snell's law of refraction. So these two are known as the laws of refraction. The first law says that the incident ray, refracted ray and the normal to the refracting surface lie in the same plane, and second law, which is also known as the Snell's law, says that ratio of sine of angle I to this and sine of angle R is a constant, and this constant is known as the refractive index. Now, for white light, when it enters obliquely from one medium to another transparent medium, we know there is refraction taking place. And for white light, how much is the extent of this deviation of the path? That can be understood by the term that is refractive index. Refractive index. refractive index shows how much the extent of deviation when light enter from one medium to another medium. And we know that deviation depends upon the speed of light. Because speed of light in all medium, it is not same. In different media, the light travels with a different speed. So that extent of bending, that extent of the deviation of the path, changing the path of the propagation of light is expressed in terms of refractive index. So suppose we are considering two media here. The medium 1 is air and here the medium 2 is glass. Air is medium 1 and glass is medium 2. When we consider a ray of light that entering from medium 1 to medium 2, we know since the mediums are different, speed of light is different, there will be a change in the direction of propagation. And how much is that extent of change in the direction? That is explained in the terms of refractive index. And refractive index is denoted by the letter N. N shows refractive index. Now the light ray that is entering from medium 1 to medium 2, then the bending of the light ray here takes place because of the difference in the speed of light. Here that can be found out how much is the extent or how much is that extent of change in the direction of propagation, that is known as the refractive index of medium 2 with respect to medium 1. So the refractive index of medium 2 with respect to medium 1 says how much is the extent of that deviation of light that has taken place in medium 2. And we know it depends on the speed of light. So we can express this as the refractive index of medium 2 with respect to 1. This same can be written as like this also, refractive index of medium 2 with respect to 1. Anyway, you can express this. The meanings of these two are same. Here it says this is the refractive index of medium 2 with respect to medium 1. That will be given by the speed of light. What is it? It will be the ratio of the speed in these two different medium. The ratio of the speed of light in these two medium will give the refractive index of this medium 2. So, refractive index of medium 2 with respect to 1 will be given by speed of light in medium 1 upon speed of light in medium 2. So ratio speed of light in medium 1 to that of medium 2 will give the refractive index of this medium with respect to 1. If any medium in this way, when refractive index we express in that case, if one medium is, the first medium or medium 1 is air, that is known as the absolute refractive index. If medium 1 is air, that is known as absolute refractive index. So here we can say the refractive index of this glass is also known as absolute refractive index, or simply it is called as refractive index, because here the light comes from air to glass, or the first medium, that is air. So in this case the refractive index of this glass is also known as absolute refractive index. That is absolute refractive. This is also known as absolute refractive index. Now from this glass, when the light ray enters out from this glass to air, when it moves out, when it comes out, propagate out, now the refractive index of this medium, if it is any other medium, maybe air or water or any other medium, suppose if it is medium 3, It's not air, instead air to glass and glass to any water or any other medium the light travels. Now this refractive index of medium 3, that is considered by, that is called as the refractive index of medium 3 with respect to the medium 2. Or if it is air, again back, suppose if it is air, when we consider it that the light now enters from glass to air back. So that is again medium 1 only here. If it is air again here, that is medium 1 only. So in this case now we are saying the refractive index of medium 1 with respect to 2. That is also written as refractive index of medium 1 with respect to 2, and that is obtained as, this is obtained as speed of light in medium 2 upon speed of light in medium 1. So this is the way in which refractive index is expressed. And as we told just now, when light enter from air to any medium, when the first medium is vacuum or air, the refractive index is known as absolute refractive index, or simply it is called as refractive index. So that can be expressed as refractive index of any medium. Here it means that the light enters from air to any of the medium. In this case, the refractive index of this particular medium is expressed as speed of light in vacuum to speed of light in that particular medium. So, since speed of light in vacuum is denoted by C, and the speed of light in that particular medium, that is V. So this is the expression for the absolute refractive index of any medium, that is speed of light in vacuum upon speed of light in that particular medium. Now this equation, this refractive index equation, can be utilized to find out either the refractive index of the particular medium or the speed of light in various medium. If we want to calculate, if we want to find out the refractive index of any medium, and we know the speed of light in that two different media, in respect to that media, suppose refractive index of medium 2 with respect to 1, if we want to calculate, and we know the speed of light in medium 2 and medium 1, we can get the refractive index easily by putting the equation speed of light in medium 1 divided by speed of light in medium 1 upon speed of light in medium 2. So this can be utilized to find out the refractive index, either absolute refractive index or the relative refractive index. If one of the medium is air, we call it as absolute refractive index, and if it is two different media, it is known as the relative refractive index. At the same time, if the refractive index is given and speed of light in any one medium we know, we can also calculate the speed of light in the other medium by using this expression. So this is about refractive index of a particular medium. Now, refractive index, or it is related to that optical density as we told earlier. Optical density is nothing related to mass density. That means if any medium that is having a higher optical density may have lower mass density also. It is nothing related to mass density. Here it is depending on the speed of light in that particular medium. So vacuum, if any medium is having higher refractive index, in that medium light travels with the lowest speed, and if in any medium the refractive index is least, in that case the speed of light is maximum. And it is observed that in vacuum, which is having the low refractive index, the speed of light is maximum, and the other case the diamond, which is the hardest substance, where the speed of light is very slow. Thank you.